All right, the final section of Calc 3, the divergence theorem. Oh, I just noticed a typo here. There should not be an equal sign here. That should hopefully be obvious. But let's just get rid of that. So be mindful of that. All right. So the divergence theorem says that the flux of F through the surface of through the surface del W. So think of W as a closed. Think of W as a three-dimensional region. So maybe it's a sphere. Okay, and not just the actual surface of the sphere, but actually think of this as being the solid sphere. So everything within. So think of a solid ball, not just the shell, but everything within. That's W. So if W is the solid sphere, in other words, it's the set of all x squared plus y squared plus z squared. Let's assume this is the unit sphere, and then this would be less than or equal to 1. Equals 1 is just the actual shell, the outside. If it's less than or equal to, it's that shell that we're used to, but then everything filled in. So del W in this case would just be the sphere itself. W is the solid sphere. So there's an example. Then, if you want to know the flux of a vector field through the surface, divergence theorem says all you need to do is integrate over the full volume of the sphere and check, and you would integrate the divergence. And the divergence tells you the extent to which at every single point in here, if you zoom in close enough at that point, it tells you to what extent are the field lines exiting some region, or perhaps maybe the field lines are entering some region. So this is a local measure, let's say, on the degree to which the vector field is outwardly flowing from each point.